We're going to begin our discussion of capital structure with a review of break-even analysis. This is something you've probably run into before, but we need to review it in order to lay the foundation for the leverage discussion that is probably new to you. So we want to figure out at what level of sales our operating income equals zero. And so we're going to have certain costs that are classified as being fixed, and that means that they remain constant as quantity produced changes. And then there are other costs that are deemed to be variable, and these costs change as the quantity of output that we produce changes. I think it's important to note that there is some judgment here. There's not a big label on every cost that clearly makes it fixed or variable. So anyhow, the red line here is our variable costs. The blue line here is our fixed costs. And fixed costs might include salaries, depreciation, rent, although as I indicated, there is some judgment here. Companies have been known to lay off workers, which would convert a salary expense into a variable cost, but we'll stick with sort of the norms of what analysts tend to use. On the variable cost side, we'll have commissions, materials and labor that go into our cost of goods sold. And so we want to find the quantity that makes EBIT or operating income equal zero. That is the quantity of units sold. So the break-even point is your fixed costs over your price per unit minus your variable cost per unit. So if we have fixed costs of $1 million per year and price per unit of 800 and variable cost per unit of 400, we would have 2,500 units that we would have to sell in order to break even. On the revenue side, total revenue, price per unit times quantity sold. And so here you can see the different total revenue scenarios with different unit sales assumptions here. And so let's look at this graphically. Fixed cost is a horizontal line because it does not go up or down as the quantity produced goes up or down. Variable costs are zero if you don't produce anything, and then they go up as you produce more and more and more. So you'll notice that this is a straight line, so whatever your variable cost per unit happens to be tells us the slope of this particular line. So the slope of the variable cost line is your variable cost per unit. For every additional unit produced, my costs go up by whatever my variable cost per unit happen to be. So the slope of a line is delta y over delta x. So the change in costs over the change in quantity produced gives us the variable cost per unit as the slope of this red line. And then the total costs is just the red line shifted up by the amount of the fixed costs. And so you can see that we have $1 million worth of fixed costs, and the slope of the yellow line is the same as the slope of the red line, the variable cost per unit. And we can superimpose the total revenue line on there. The white line, if I don't sell anything, I don't have any revenue. The more I sell, the more revenue I have. How much more? Well, it depends on what the price per unit is. So if my sales price is $800, if I sell one more unit, my revenue goes up by 800. If I sell another unit, it goes up another 800. If I sell another unit, it goes up another 800. So the slope of the white total revenue line is your price per unit. So you can see the the break-even point is where your total revenue line, the white line, intersects with the total cost line, the yellow line, and you can see it's at the 2,500 units that we computed earlier, and our total revenue and our total cost would equal $2 million here. And so we have 2,500 units being sold times $800 each. That gives us $2 million worth of revenue. And at 2,500 units produced, we have $1 million in costs plus $400, the variable cost per unit, times 2,500. So right there, the two numbers, total costs and total revenue, are equal at $2 million. This leads us to the concept of leverage. You may have run into this in a high school science class. I think most of us have heard of a lever. That little thing there is called the fulcrum. That thing there is the lever. This is the object that we're trying to move. And if I push down on the end of the lever, I can move the big boulder that might be too heavy to move without the assistance of the lever. And the longer the lever, the bigger the rock you can move. If you ever tried to change a flat tire, you know that you can put the lug wrench onto the bolt, and if it doesn't change very much, then what you can do, if you're still not able to loosen the lug nut, you can put an extender onto the lever there, and this is going to allow you to undo the frozen lug nut more readily than what you could before. So there's some sort of a magnifying effect when you use a lever. You magnify the work that you're able to do, and so that can be helpful in certain circumstances. We're going to see in a financial context, it can be helpful or it can be hurtful depending on what else is happening within the firm. So the operating leverage phenomenon is related to the fixed costs in the production process of the firm. When a company has high fixed costs, a small change in sales will trigger a relatively large change in operating income. So we have something called the degree of operating leverage that we can compute. It's the percent change in EBIT over the percent change in sales. Remember that operating income is another name for EBIT, and so if that number is greater than 1, it means that your operating income is changing by a larger percentage than your sales, and this is causing a magnifying or a leveraging effect. So here's our company with the 3,750 units being sold in year 1, and they're predicting 5,000 units to be sold in year 2. Here is the cost structure that was alluded to earlier. $1 million in fixed costs, $400 per unit variable costs, $800 per unit in sales price. And so your sales revenue at the 3,750 units that we sell in year 1 is 3,750 times $800 per unit equals $3 million. Your operating income is equal to $3 million minus $1 million, that's your fixed costs, minus $1.5 million, that's your variable costs. Where did I get $1.5 million? I just took 3,750 and multiplied by 400. That leaves me with $500,000 of operating income. Now we go to year 2, when we expect to sell 5,000 units. Our revenue is 5,000 units times $800 per unit, or $4 million of total revenue. Our operating income is $4 million minus that same $1 million fixed cost number, because it is fixed, minus $2 million in variable costs. because our variable costs are now equal to 5,000 units times $400 per unit. So our operating income in year 2 is now $1 million. So our degree of operating leverage is the percent change in operating income. 1 million minus half a million over half a million equals 100. And 4 million minus 3 million over 3 million is equal to 33 1/3. So you have 100% over 33 1/3%, which equals 3. You'll notice I dropped all the zeros here, and I did so consistently. You can check my math if you wish and plug in the full $1 million, $500,000, that is the 500,000, 500,000, 4 million, 3 million, 3 million. I think you'll find that my math is correct here. So the degree of operating leverage is equal to 3. Now we have an alternate formula for this. Using the base year, the year 1 figures from which those percent changes were computed. If we take the sales minus the total variable costs, divide by the sales minus the total variable cost minus the fixed costs, all these numbers coming from year 1, you'll see that we get 3 million minus 1.5 million over 3 million minus 1.5 million minus 1 million equals 1.5 over 0.5, which equals 3. So you can see that the percent change version of the operating leverage formula gives us the same number as this alternate version of the formula. So the reason why we have this alternate version of the formula is to help us to understand the source of this leverage effect. See, we have the minus fixed costs in the denominator here that does not appear in the numerator. So that's the only difference between the numerator and the denominator. So if we had no fixed costs, if our fixed costs were 0, then the numerator and the denominator would be the same and the degree of operating leverage would be 1. That is, there's no magnification going on. The percent change in your operating income is the same as the percent change in your sales. But as soon as we start subtracting something out of the denominator that's not subtracted out of the numerator, then this number becomes greater than 1, in this case 3. So in this case, the percent change in operating income is 3 times the percent change in sales. And so we identify this very important variable here, the fixed operating costs of the firm. And so this helps us to have a better understanding of where this leverage is coming from. And so let's move on, just kind of show you here that the degree of operating leverage varies when sales vary. It falls as sales rise. So at 3,750 units, our degree of operating leverage is 3. If your units sold were 5,000, it would be 2. If it were 3,250, it would be 4.33. If the quantity sold were 2,500, it would be undefined because you would be dividing by 0. So I'll leave it up to you to go back and plug the numbers in here and show that what is described in this table is in fact correct. Next, we move on to financial leverage, which picks up where operating leverage leaves off. Operating leverage focuses on change in operating income relative to change in sales. That's the top half of the income statement. Financial leverage deals with the bottom half of the income statement. It comes from having fixed financial costs, such as fixed interest on your debt, fixed preferred stock dividend on any preferred stock that your company has issued. And so the degree of financial leverage is the percent change in net income over the percent change in EBIT. And so we can compute that number. Here are our EBIT numbers for year 1 and year 2. Here are our net income numbers for year 1 and year 2. So the percent change in net income is ending value minus beginning value over beginning value, gives us 167%. And the percent change in operating income is the 1 million minus $500,000 over $500,000, which is a 100% change. So the degree of financial leverage is 1.67. Once again, we have an alternate version of the formula using year 1 figures, EBIT over EBIT minus I. That is earnings before interest and taxes over earnings before interest and taxes minus interest expense. Once again, you can see that this minus interest expense is the key here. If interest expense didn't exist, such as if the firm were all equity financed, meaning it had no debt, it would have no interest expense, and its degree of financial leverage would be EBIT over EBIT, or 1. As soon as we start subtracting some amount out of the denominator, because the company has this fixed financial cost, the interest expense on its debt, we're going to make the overall number greater than 1. And in this particular case, the number is 1.67. So the percent change in our net income is 1.67 times the percent change of our EBIT, our operating income. We can combine these two effects and compute the percent change in our net income over our percent change in sales. And so here we have the numbers for years 1 and 2. The percent change in net income is your 480,600 minus your 180,000 over your 180,000 equals 166.7%. And again, I dropped the zeros. You can check my math and see if you get the same result using the full dollar value. Divided by 4 million minus 3 million over 3 million, which is 33.33%, and 166.7% over 33.33% is equal to 5. So the percent change in your net income is 5 times the percent change in your sales. Now, I want to emphasize that all these leverage numbers that we're computing, degree of operating leverage, degree of financial leverage, degree of combined leverage, they work in both directions. That is, the percent change in your sales could be positive, meaning your sales are going up, in which case your net income would go up by 5 times the percentage. The percent change in your sales could be negative, which means that your sales are going down, in which case your net income would go down by 5 times the percentage as the decrease in your sales. So leverage cuts both ways. It magnifies things in the upward direction, and it also magnifies things in the downward direction. We can notice here also that the degree of combined leverage is the product of the degree of operating leverage that we showed earlier was 3, and the degree of financial leverage, which was 1.67. And so the product is 5. And here's another way of expressing that degree of combined leverage, again using the year 1 figures, the base year figures, from which those percent changes were computed. You can see the difference between the numerator and the denominator is these two things that are subtracted out of the denominator that are not subtracted out of the numerator. This is your fixed operating costs, and this is your fixed financial cost coming from that interest expense on your debt. And so once again, we get that 5 value, and so we can see the source of the combined leverage effect here. So I want to emphasize that leverage can help a firm when sales are going up. leveraging those upward movements is a good thing. When sales are going down, leveraging those downward movements is a bad thing. And so we have the leverage effect here, and we can see how the changes in operating income, EBIT, affect the net income of the firm. Now, this leads us to a further discussion of the debt that is the key to the degree of financial leverage. And one of the benefits of debt financing is that interest is tax deductible to the paying firm, whereas payments to equity providers, that is the stock investors, are not. I don't want to overemphasize this, however. If you think back to Chapter 2, you're going to recall that the cost of debt is lower than the cost of equity, even without consideration of the tax deduction. So the fact that we have a certain benefit associated with debt, that is, it has a lower cost than equity, and it has a tax deduction that equity doesn't give us, means that we have to evaluate this benefit against the negative with debt, which is that the financial risk of the firm goes up every time you borrow more money. So debt is constantly presenting us with a good news, bad news kind of scenario. And so what firms try to do is to balance these costs and benefits in order to find the optimal mix. And when you find the optimal mix of debt and equity, then you are maximizing the value of the firm. This is the place where you're minimizing your weighted average cost of capital. So when you add debt to your capital structure, if you start out from a no debt scenario, the use of debt will initially lower your weighted average cost of capital. As you continue to add more and more debt, at some point you're going to reach the point where you are now increasing your weighted average cost of capital, and this is a bad thing. You are not maximizing the firm when your weighted average cost of capital is going up. So we have this diagram that illustrates the concept. You can see this red curve here is the cost of debt, and it is everywhere lower than the yellow cost of equity curve. The green curve is the weighted average cost of capital. So we start out here with a 0% debt to firm value ratio. That is right here at the origin on the x-axis. We have no debt, which means that this is a 100% equity financed firm. The vertical axis is the cost of capital, the cost of debt, cost of equity, weighted average cost of capital. So if we go from a zero debt firm to a small positive debt firm, you can see that the green curve turns down a little bit. And that's because we're substituting a little bit of the much cheaper debt for the much more expensive equity. So the weighted average cost goes down. And so we can move a little bit more to the right and see that the green curve, the weighted average cost of capital, K subscript A, goes down again. It goes down again out to here, and again, until we get out here to this double-headed red arrow, where the weighted average cost of capital, the green curve, is minimized. And to the right of that, you can see that additional debt, that is, as we move to the right on the horizontal axis, which means we're adding more debt, the weighted average cost of capital goes up. And the reason for this is that the cost of debt is going up and the cost of equity is going up. And at some point, the weighted average cost of capital is going to go up also. So we are optimal right here. Let's call that 40%, just to ballpark that. So this firm optimizes its capital structure at around 40% debt. And so every firm wants to find its optimal. This firm, it's 40%. It might be 25% for a different firm. It might be 80% for a different firm. Every firm is different. So what I want to emphasize here is every step that we take to the right on the horizontal axis, that is, every time we add more debt, a good thing and a bad thing happens. The good thing is we're substituting more of the cheaper debt for the more expensive equity. See, at no point is the red curve higher than the yellow curve. So it is unambiguous that debt is cheaper than equity for a given firm. And so using more debt gives us lower cost funds. That's a good thing. The bad thing that happens is more subtle. And so I need to talk you through this. Every time you add more debt to your capital structure and move to the right, the financial risk of the firm increases. And that's a bad thing. And so you can see investors in the firm's equity start to demand higher and higher required rates of return, because if the firm is getting riskier, the people who are getting paid last, the equity investors, are going to demand higher rates of return before they are willing to part with their investment dollars. The same is true with lenders. At some point, the cost of debt goes up. You know this. If you walk in to apply for a loan and you already have lots of credit card debt, lots of student loans, big car payments on a car loan, the interest that you have to pay on a new loan is going to be higher. And so this diagram is describing these realities. And so only when you have the perfect balance of the cost advantage of debt versus the risk advantage of equity, that is, using equity funds lowers the risk of the firm, then you have the optimal capital structure where the weighted average cost of capital is as low as it can be. So just to wrap up here, I wish I could tell you that there's some formula that tells you where this double-headed red arrow is, but this is something that financial executives learn from experience. There are some firms that could handle 80, 90% debt, and nobody would get too worried because they're very, very profitable, growing firms. Think Microsoft. There are other companies for whom modest amounts of debt would be considered dangerous. Think Chrysler or Sears. And so every firm needs to try to figure out, by looking at other firms in their industry and experience that comes from seeing different kinds of capital structures for firms that do what you do, you can estimate what the capital structure ought to be. In this case, it's right around 40%. So that wraps up chapter 13.